Hey everyone, my name is Puru and I welcome you to this channel. Today we are looking at the problem longest increasing subsequence. It is a medium level problem, but it is on the difficult side of the medium spectrum. Now let's look at this problem. Given an integer array nums, return the length of the longest strictly increasing subsequence. Strictly increasing means it can't be equal, it has to be increasing, and subsequence, it means that it doesn't need to be continuous. A subsequence is a sequence that can be derived from an array by deleting some or no elements without changing the order of the remaining elements. Example, 3627 is a subsequence of 316227. Now this is only a subsequence example, not an example of the LIS. Now let's look at the example 1. So here we have an array 10, 9, 2, 5, 3, 7, 101 and 18. Now we need to find a subsequence that will have the longest increasing length. So if we select 10, then we have only 101, so no. If we select 9, then again we have 101, no. So if we select 2, now we have 5, then we have 7, then we have 101, so we have length 4. Now we select 5, then we have 3, then we have 7, then we have 101, that is length 3. Now if we select 3, then we have only 2, but we can also select 2, 3, 7, 101. So there can be two possible options. After 2 we can select either 5 or either 3. So now this makes this problem a little bit challenging, that we can select certain numbers and we can tend to ignore those numbers. So in this way we have two possible cases for each element. Either we select it or either we reject it. So this makes our complexity for this question exponential, that is 2 raised to power the number of elements, that is 2 raised to power n, because for every element we'll have two options. So now there's another approach that is based on dynamic programming. So now let's suppose we are at 101 and we somehow know that what will be the length of the subsequence at position 7. Somehow we know that. So let's suppose at 7 it's 3. Now we know that at 3, if we go to 101 is greater than 7, so the length will tend to increase at 101 only. Now let's take an example and consider we know the values of the longest increasing subsequence till this part, up till 7. So for 10 we know that there's only one element because it's the first element, and for 9 also we know that there is no element that is smaller than this, so length is only 1. For 2 there is no element smaller than this, so length is 1. For 5 there is 2, so our length will be in this case 2. For 3 again 2 because there is only one element. So up till 7 we can see we have length 1, 1, 1, 2, 2. So now obviously till this position we will choose the subsequence that will have the greatest length, because 7 is greater than 3, 5 and 2. So we'll have two conditions to check. If the number that we are looking at is greater than the number that is occurring, and also we'll check the length of the subsequence for that previous number is less than what we will have after including this number. So this is a DP based problem. So now let's look at the example number 2 to have a better understanding. So now let's suppose we are at this position 2. So we know the length up till this part. So for 0 we'll have length 0. For 1 we'll have length 1 because it will be 1 and 0. For this 0 we'll have length 0 because none of these numbers occurring before it greater than 0. For this 3 we'll have length as 2 because we'll have this 0 and 1 coming before 3. So the length will be 3 up till this part. Now let's look at 2. Now 2 is less than this 3. So we can't check for it. But we can check for the other elements. Yes, 0 is less than 2 and the length here is 1, so we'll go ahead. For 1 is less than 2, yes, and the length here is 2. Okay, then we go to this 3. So here 3 is greater than 2 and the length is 3. If we include this 2, we can't include this 2 because this 2 is smaller than 3 and that will break the sequence. So up till here we have maximum length of 3. Up till here we have maximum length of 3 and those two possible cases are 0, 1, 3 or 0, 1, 2. Now let's look at this position, this 3. Now we know that it's 1 over here, it's 2, it's 0, it's 3 and it's 3 over here too. Now 3 is not greater than the 3, it's equal to 3. So we can't check for this, but this 2 is less than 3 and the value of the length that sequence that we have here is 3. So we can increase it and our final length will be 4. I hope you get this. So now let's initiate, let's write the code. We'll create an array of the length of numbers array so that we can have the length of the sequence up till that position. Okay, so now we'll go create a loop for int I is equal to 0, I is less than nums dot length. For int j is equal to 0, j is less than I, j plus plus. We'll initiate to 1. I am initiating I is equal to 1 and j is equal to less than I because we need to compare. Let's suppose we were at this element 2, so we were comparing up till the previous one. So obviously when we start the array, we'll start with this one and compare it with the previous one. So that is why I'm starting this array from this loop from 1 and the inner loop up till that position. So now we'll add in a condition to check if this ith element is greater than the jth element and also the length of the subsequence created up till here is not actually greater than the length that is at that will be created at this step. So now if that is the current cell versus the part we are iterating over. Now we'll have to look over. This can be equal. If this is the condition, then we increase dpi is equal to dp j plus 1. Now we'll just sort this array return arrays and dp nums dot length minus 1 plus 1. Now why am I adding 1 over here? Because we aren't because the element that is at ith position, that will also be included in the array and I'm not counting that particular element while doing this step. So I'll need to add an extra one so that I can compensate for it. Let's run it. Okay, let's submit it. Okay, so this was the approach. This is an approach that will take n square time, and this question is asked if you can come up with an algorithm that will run in O of n log n. And to be honest, I wasn't able to figure that one out. I was only able to figure out this one. So if I get a chance to work upon this problem and get a solution that will be in O of n log n, I'll make sure to update you guys with it. So that's it for now, and I'll see you guys in the next one.